Hi everyone, welcome back to PRAKASAM tutorials. In this video, I am going to discuss about spectral characteristics random process introduction, stochastic process or random process spectral characteristics introduction. In previous chapter, we have studied the characteristics of the random process in the time domain. The characteristics of the random process can be represented in the frequency domain also, and the function obtained in the frequency domain is called the spectrum of the random signal. And the spectrum of the random signal is measured in volts per Hz. Both the time domain and the frequency domain analysis methods exist for analyzing linear systems and deterministic waveform. The main purpose of this chapter, so that is spectral characteristics of the random process or spectral characteristics of the stochastic process, the main purpose is to the random process in the frequency domain. Random to random process in the frequency domain. The spectral description of a deterministic waveform is determined by the Fourier transforming the waveform. So x of t is the time domain signal in signal sense system. Now here the signal x of t is the random signal or deterministic signal. The Fourier transform of the random signal or the deterministic signal is given by mathematically Fourier transform of x of t is equal to x of omega, which is equal integral minus infinity to infinity x of t into e power minus j omega t dt. So this is the equation of Fourier transform of a random signal or the Fourier transform of the deterministic signal. Now here in this equation, x of omega is considered to be the voltage density spectrum of x of t, and its voltage density function of the spectrum of x of t is measured in volts per Hz. But the problem is that x of omega may not exist for many functions of a random process. Therefore, the spectral representation of a random process utilizing the voltage density spectrum is not feasible always. In such cases, we go for the power density spectrum of a random process. So which is defined as the power spectrum density of a random process is defined as a function which results when the power in the random process is described as a function of frequency. If x of omega is known, then x of t can be recovered by means of the inverse Fourier transform of x of omega. So the previous expression is the Fourier transform of a random signal, that is x of omega. Okay. So if x of omega is known, then we can determine x of t. That x of t is called as the inverse Fourier transform of x of omega. So the inverse Fourier transform of x of omega is given by or defined as x of t is equal inverse Fourier transform of x of omega, which is equal 1 by 2 pi integral minus infinity to infinity x of omega into e power j omega t d omega. So this is the introduction to the stochastic process or the random process spectral characteristics.